All right, welcome back everybody. We're still in the technical tools module, focusing on some of those technical skills. Again, just as a refresher, kind of in that technical tools area, there's the two main things we focus on, which is tools to measure, tools to improve. The tools to improve is what we're covering, and that's kind of the skill side from the technical perspective of how we want to go about affecting this lean transformation that we're after. So in this kind of first subset of tools, we're going to be covering Jidoka today. Stability, problem solving, and standardized work were covered in the previous sections. And so in looking at Jidoka, one of kind of the foundational understandings of what we're trying to accomplish with that is this idea of building in quality. And kind of as par for the course in these sections, we're going to do some comparing and some contrasting with kind of the typical traditional way of going about thinking of these concepts versus how we want to shift our approach to kind of this lean concepts, lean thinking ideas. And so in the traditional model of building in quality, if we lay out just a sample production line right here, just 3 basic processes, at the end of that, normally we have some level of inspection, some quality control, some quality inspection process at the end, catching the product as it comes off the line. And the results of that quality check is generally, if there is a defect, we can rework it if it's possible, or if not, we scrap it and we have to make a whole nother unit to begin from the beginning all the way through. And then the items that pass inspection are considered good and we can go ahead and ship those. Now there's a couple major problems with this kind of traditional approach to building in quality. And where that really comes from is that when we're only inspecting the finished goods, we're not really providing any feedback to the operations that are generating these defects, right? These people don't know, those processes don't know that they're creating a defect because it's not getting found until way down the line, and then maybe that isn't being communicated back up. Also, if we're only checking for defects at the end, when we find one, now we have a whole production line full of things we have to go back and rework. Outside of that, this idea of scrap and rework, by not catching things early, this rework operation, the scrap operation, is kind of a hidden factory idea, going back to some of the terminology from the measurement module, where that's waste. We may not think about it as waste because in the end a good product still goes out the door, but that's extra time, extra money that we're spending on each product that we have to rework because we didn't catch the defect early enough to do something about it before it became a major problem all the way at the end. So what we want to switch to with a lean thinking, a lean approach, is we can lay out that exact same 3-process sample production line, but what we want to do is we want to make sure that each process only ships quality product. So each operator within each process has a firm understanding of what is a good product, what is normal, and what is abnormal. So when there is a defect, they can see it, they know what it is, and they can do something about it. And what we do with that is these arrows going backwards represent, say in process B, there's the next item coming down the line is received and there's a defect with it. Well, we don't just say okay and pass it down. We want to send it back immediately to have it repaired as soon as possible. And what the kind of sum result of that is that we can be sure then that when things get to the end of the line, because we're checking for quality, we're ensuring good quality, we're not moving product through the line unless it is good quality, that by the time it comes off the end and it's ready to go, every item that comes off the end of the production line is okay to ship. And so the main things that we get out of that is that when we don't pass those defects, when we fix them in the process, we don't have to have that extra rework and scrap operation at the end. We can eliminate it completely because we're making sure that we're building good product the whole way through. The other thing that comes out of it is that now our operators in each stage get immediate quality feedback. So if they make a defect, they know about that immediately before they have a chance to reproduce that defect on maybe 100 or 1,000 parts before someone says something about it. The last thing, again, that kind of ties into that is that now we're finding these defects at the source. So when we do have a quality problem, we don't find it in inspection and now have to figure out where it came from. We find it immediately at the source, so it's easy to see what happened, so it's easy to fix that effectively and quickly. That's the major things that we accomplish with this model. So then we want to look at, okay, now we understand why we want to do it, but how do we go about doing that? Kind of how do we do it from a management and a technical system? And so the way that's laid out is pretty simple. We can take any given process, and we want to do this for all of our processes. we want to have some mechanism to make abnormalities visible, whether it's standardized work from what we talked about before, or some other mechanism that the operators can see when something has happened, something abnormal has happened. Then we want to provide them with a mechanism, a tool, to be able to call for help, to say, I need some assistance in dealing with this defect because I don't know what to do with this, or I can't keep up with everything else and try and fix this at the same time. Now, once they call for help, now we have to have a management culture where there's an immediate response. We treat that call for help with some urgency. We don't just let it sit for a day or 2 days or 3 days. We go and respond immediately. And then the fourth step there is we want to implement good countermeasures. That ties in being able to problem solve effectively, and it ties into using some of these skills that we're going to be developing in these next sections in order to develop those effective countermeasures to solve these problems as they occur in real time. And the end goal with what we're trying to do with this is we want to prevent the defect. So when we have something, we want to prevent it from getting worse, and we want to be able to address it immediately so that we don't have a recurrence of that same defect. By the same token, now that we have this way to build in quality at each process, we have a way to make sure we're not passing the defect along and letting that snowball roll down the hill. Those are the main things we're after with this. And so there's a couple tools that we can use to help build in quality. One of them is an andon, which really all an andon is kind of like a warning signal. Like we said before, we need some mechanism to stop and call for help. That's what an andon is. And there's two main kinds. There's a human andon, which can be a flag or a light or a pull chain or a siren, a whistle, whatever. And then we have machine andons. And really what the andon is it's something that kind of developed out of the supervisor's need to be able to see where problems are cropping up. And it's a tool for visual control because now we can see a problem when it happens in real time. That flag goes up, that light goes on, the siren goes off. We know something is happening. We know we need to respond to that now. If we don't make it visual, if we don't notify of our abnormalities, 9 times out of 10 in a traditional setting, people just aren't aware. Management isn't aware of the problems that are happening, which makes it impossible then to do anything about solving them. The other tool, and this is something pretty simple, is called a poka-yoke. It's a funny word. But really what it is it's just something that's practical, inexpensive, something really easy to do. In the case of this sample, it's that simple fixture. And what it's designed to do is to eliminate defects or make it harder for defects to occur. A lot of these come directly from team member input because they're the experts, they know best. And the only way we really find out if we need these or where we can need it is by being involved at what's happening kind of on the shop floor where the value is being added, that go and see mentality. So just kind of as an example, this particular fixture was brought up because the team members were having issues with pipes lining up down the line. So the suggestion was, well, let's make a simple fixture that costs $2, and then we can save hours and hours and hours of time reworking all these pipes way down the line because we can make sure that they're right up here at the front. That's kind of the concept of a poka-yoke, right? Small things that have a big impact. Now this other concept of Jidoka, the first one in terms of building in quality and kind of notifying of abnormalities, kind of that visual cue to make abnormalities visual. The second kind of pillar of Jidoka, the second aspect of it, is this notion of separating man's work, human's work, from a machine's work. And so what we've got in this example is in here where you have one individual and one machine. When we look at the timeline, to the right there, what that shows is that for the human work, there's a couple steps. They unload the finished part, they add the new part, and then they wait while the machine runs, right? That's a concept of waste, right? We're not respecting the human capacity by asking them to wait on a machine. So what we want to do is we want to separate man's work from machine's work and get into this idea of one man, one individual, and several machines. And so when we look at the example the way it's laid out now, in one cycle time, for man's work, they can unload the part and reload the part in the first machine, turret A, turn it on, and then we stagger it so that while the first machine, turret A, is running, they can unload and reload the part in turret B. And so now what we've done is we've decoupled the human work from the machine work. So the human, our team members, can work straight through, and the machines can run straight through, and they're not waiting on each other. We eliminate that waste and we eliminate that downtime. And so just kind of to help bring that home, there is a quick little example video. that I like to show, and this is based off some work that was actually done. So talking about the first principle of Jidoka, this idea of separating man's work from machine's work. What we'll see in this video, in this particular instance, is for quality control validation of these units, the team member there actually had to sit and do some time studies on these units. And so we were asking this individual to sit essentially with a stopwatch and every 15 seconds for maybe an hour, 45 minutes, just jot down a number, right? Not very respectful of his capability of what he could be doing. There's plenty of other things more valuable that he could be doing than sitting there with the stopwatch writing some numbers down, right? And so what we wanted to do is we wanted to look at, okay, how can we separate that work out? And I think coming up, we'll see kind of what the total waste was, and you know, what really kind of brought the focus to this in particular. And so we can see right there, we noticed, because the individuals working on this project saw that this was becoming a bottleneck, and once they went and looked, you know, go and see, they were able to find that the total human work time here was 47 minutes, and 45 minutes of that was sitting there with the stopwatch, not being able to do other things. So in order to separate the work, what they developed was to come up with a computer system. So now the team member can load the machine up, hit start, walk away to go do more valuable work, and the computer now can monitor the machine system and do that work. And so what we'll see now is he can come back when the system's complete, double check that everything was okay, and then go about you know, the other critical things that he needs to be doing, troubleshooting other units, doing repairs, things like that. And what we're able to do there is now the total human work time in that instance went from 47 minutes down to 3 minutes. That's 42 minutes per unit that could now be spent doing other value-added work. That's the real key idea of separating the work. Now here for the second principle, the stop and notify of abnormalities. In this instance, one of these units has just had a critical error that needs to be repaired. But can you tell which one it is? And the problem was that no one else could either. And so when it wasn't immediately obvious that one of the units had a problem, in this case, no one found it for 7 hours. That's 7 hours of lost production. That's 7 hours that unit took up space on the floor. That's 7 hours longer the customer had to wait, which in this case snowballed to maybe a few days or a few weeks. So to correct it and to put something in place to stop and notify of an abnormality immediately, we developed a new system here to notify when something happened. And we're about to see an example of it. And there it goes. So when the equipment faults now, it triggers that red flashing light. So someone can see what's going on. In this case, the team member was doing something else, but knows to kind of keep an eye out for those lights. As soon as it faulted, he was able to come right over, fix it, get it running back so that everything could continue smoothly. And that's what we see. Once it's visible, we don't lose the processing time. So we were able to save human work time by separating human work from machine time. And then we were also able to save processing time by being able to see and fix problems when they first happen, instead of finding out way after the fact when it was too late to do anything. That's the real value of Jidoka. And so just kind of in summary, you know, to wrap that up, you know, why it really matters is that when we can build in quality and we can kind of maximize our human resources, that really helps us drive towards our ultimate goals of highest quality, lowest cost, and of course shortest lead time. These two things, the concept of Jidoka, the skills that we've talked about with this, are really, really valuable and can be used in almost any incarnation and should be used in every process to make sure that we're being efficient and effective with our problem solving and our human resource. So that covers this section. You know, as always, any questions, please send them through the website, and we will see everybody for the next section. Thank you.